Good morning, good afternoon, or good evening. This is going to be a full work through of the Further Maths practice paper released last year. This is going to hopefully be, as much as possible, a blind look at it. Of course, I have glanced through this a couple of times, but haven't prepared anything for this, and I hope to give my first impressions of a lot of these questions as we work through. Let's get going. So question 1, work out the distance between those 2 points using the formula the square root of the change in the x coordinate squared plus the change in the y coordinate squared. Now it doesn't matter whether which order I put the coordinates in, first then subtract second or second subtract first. I've just done it here to make the numbers the most pleasant and avoid negatives. Of course it does matter when you're doing gradient. Now notice this is the non-calculator paper, so I'm adding those extra lines working just to allow my my working to keep up, my mental arithmetic to keep up. Question 2 is to rearrange that to make m the subject. I don't like fractions, so I'm going to start by undoing the fractiony bit. I want m to be the subject, so I'm going to rearrange, undo the layers of the m, and we're left with the cube root of the 9p to the 5 minus 3. Question 2, that is increased by 20%. Well, to increase something, you multiply by 1.2. So t plus 10 times 1.2 makes t plus 19. Expand out my left bracket. And then I'm just going to simplify, so I'm going to bring the t over. I'm going to send the 12 the other way. Finally, 0.2t I undo by timesing by 5. So t is 35. If I wanted to, I could go back and check. It's a lot harder to check without a calculator. But that's then 45 increased by 20% gets to 54. Does that work? Well, 20% of 45 is 9. Add on the 9. Yes, indeed, that works. Expand and simplify. We have a triple bracket to try and expand and simplify here. I'm going to ignore the back bracket and just do the front 2 first. I'm going to simplify as I go. So I've got my 3x squared in the front, I've got a minus 6x and a minus 4x in the middle, and then a minus 2 times minus 4 plus 8 on the end. Expanding further, we get 6x cubed. I'm going to have a minus 20x squared plus 9x squared from the 2 ways to get the x squared term. We have plus 16 from the 8 and the 2, minus 30 plus 16 minus 30 is minus 14, and finally 3 times 8 at the end is 24. And there are things I can do to check if I did have the calculator. One of the things I like to do to check these kind of questions, I notice this bracket is 0 when x is 2, so if I put 2 into my answer it should become 0. With a calculator that's very easy to check. Without a calculator it's a bit more effort, but that's a nice way to see if you've made any really silly errors. Question 5, we have our identity symbol here, which means this is true for every single value of x, and our technique is to compare the x's on the left with the x's on the right. So I'm going to start by simplifying that left hand side, expanding out the brackets and collecting like terms. It's going to give me 7ax plus 4a minus 9, and that is equivalent to, identically equal to, 35x plus b. Well, now from the x's, that's the notation I use, is not so standard, but it's obvious what I mean. Comparing the x's, 7ax on the left must match the 35x on the right. giving a equals 5. And then if I look at the constant terms, which again I've got weird notation for, I write it as so. The 4a minus 9 equals b, but we already know a was 5. So 4 times 5 minus 9 gives us 11, and we get our two values of 5 and 11. Once again, lots of ways to check that kind of question when you come back to go through at the end. The nth term of the sequence is given by that. One of the terms is that value. Find the value of n. Well, if my nth term is given by that expression, and we're looking for when it equals that value, put them equal to. I don't like fractions, so I'm going to multiply up by the opposite fractions, multiplying up by the denominators of both, expanding out, and then simplifying, bring the numbers to one side, the letters to the other, and I'm just done. N equals 13. If I were to sub that back into the original, to have that, again, that checking technique on the top, 3 times 13 plus 1 gets me to 40. 4 times 13 minus 2, 4 times 13 is 52, minus 2 is 50, so that's 40 over 50, which does simplify as required. Write down the limiting value. Well, as n tends to infinity, the plus 1 and the minus 2 have very little impact, so you can basically ignore them. So the limiting value is 3n over 4n, but then the n's cancel, so it's just 3/4. Rationalise and simplify that. Give your answer in the form. The technique for rationalising is to multiply the numerator and denominator by the thing we had in the denominator with the flipped sign to take advantage of difference of two squares. So the numerator, I'm going to expand it out fairly slowly. It wasn't a show that question, but I'm still going to be careful with how much working I'm showing, making sure I get signs right, etc. Simplifying the top and simplifying the denominator, and conveniently both of those are multiples of 4, so I can divide both parts by 4 and get my final answer. Question 8. Question 8 is our Pascal's triangle question. So we need to start by writing out the Pascal's triangle. We need to get to the 5th row. So that's my 0th, 1st, 2nd, 3rd, 4th, and 5th. Remember how we create this is by adding the two terms from above. So I now know all my coefficients of 1, 5, 10, 10, 5, 1. I care about the x cubed term. Well, again, we always start counting from 0 in this kind of question. So 0, 1, 2. The third term is from that 10. So therefore, the third term is created by 10 times, well, the 2a, I'm not going to put the power on yet because I'll need to work that out, times x cubed. Well, the powers have to add up to the total power of 5. So this has to be a power of 2. And we've been told that that is 360 x cubed. Now I don't need the x cubed, so I'm going to cross them out straight away. And now let's simplify the left hand side. 2a squared comes out as 4a squared, so that's 40a squared. So a squared equals 9 and a equals plus or minus 3. Be very careful that you don't lose that plus or minus. The question did tell us quite explicitly to look for two possible values, so finding two values is essential. Question 9. F of x equals that thing, work out f inverse of negative 4. Well, f inverse of negative 4 is saying which way round is it saying? So that's saying f of something equals negative 4. Negative 4 is my output. So that's the same as the cube root of 2x equals negative 4. Of course, you could work out the inverse function using that method, but there's not a lot of working space and there are only 2 marks available for it. So it feels like doing it in a sneakier, quicker way is more sensible. Cubing both sides, going without a calculator, you need to be a little bit careful. X comes out as negative 32. And if I do sub that back into f, I do get negative 4, and I'm happy. Part B. We have 2 quadratic functions this time, and we're trying to solve where the g function is less than the h function. So this is just a thinly hidden quadratic inequality. So let's bring everything onto the same side. Let's factorize to find those critical values. So that's telling us that our critical points are 2 and negative 5. The technique now is to draw yourself a very quick quadratic. It is a positive quadratic with roots at negative 5 and 2. We want where the curve, we're looking at this bit here now, is below the x-axis, so I'm looking for that region there. So my answer is negative 5 is less than x is less than 2. Checking the inequality in the question, it was strict, so I do have a strict inequalities in my answer. Question 10. Trig question. Here's a sketch of the line y equals k intersects a graph at those 2 points. Write down the exact value of k. So this is asking us to recall what cos 30 is. Now you could have just memorized that little table and worked it out. I prefer to remember the triangles. I know 30 comes from half of an equilateral triangle. So up there that was the 30 and the 60. This was half of that right angle triangle. It was a two-sided because I've halved the base and this side was root 3. So cos of 30 is adjacent over hypotenuse, root 3 over 2. And then you could have just memorized that. I prefer to just remember where the what the two triangles are. Solve cos x equals negative k. So I'm going to go back up to the graph actually and draw that on. So my negative k is down here instead. And this is a nice question talking about the symmetry of the graph. So this part here is 30, so that's saying from the peak down here we have 30 there and 30 there. It's also the same up here was 30. Trig graphs are lovely, they are incredibly symmetric. So my two answers are 180 plus 30 and 180 minus 30 as my two answers. Question 11. The piecewise function. We have the function given by that for those values in various regions. We want to sketch this from 0 to 10. So a couple of things I noticed that this first one, this is a quadratic with roots at x equals 0 and x equals 4. So I know it goes through 0, I know it goes through 4. It's worth working out what f of 5 is from that first thing to see where this graph would end. That's 5 times 1, so that's just 5. Positive quadratic, I could work out where the minimum point is. By symmetry, the minimum point is going to be at 2, halfway between the two roots. So that's going to be 2 times negative 2 is at negative 4. So it does go all the way down to negative 4 at 5, 5. So I now know what my quadratic has to look like. And with a pencil and ruler, you'll be able to, well, not a ruler, but pencil, you'll be able to draw one of these graphs a lot more comfortably than I. So that's for that first section. The second section is a straight line. It's got a negative 1 gradient. And from that section, we can see again that f of 5 is 5. And I'm also going to work out the end coordinate, f of 8 is 2. So that tells me everything I need to know. This is a straight line between those two coordinates, and that certainly was not straight. straight line between those two coordinates. And then finally, from 8 to 10, we've just been told it stays at 2. This is a nice piecewise function. It was continuous, there were no breaks, but we did have to check that by looking at the 5 and looking at the 8, being those boundaries between my different parts of my curve. Question 11 done. Question 12. The first 4 terms of a quadratic sequence are given as so. Well, that's quite nasty. Okay, so we know quadratic sequence, the second difference is constant. So there we added 17. So here and here we had to add 2 numbers which are in arithmetic progression, going up by the same amount each time, to get to 16. Well, what 2 numbers add to 16? I could have 7 and 9, they go up in 2s, but then 9 can't get to 17. I have 6 and 12, that doesn't seem to work either, that goes up by 6, then we went from 12 to 17, goes up by 5. What about 5 and 11? Well, 5 and 11 does work. If I make it plus 5 plus 11, I have my second difference being plus 6, and that indeed does work. That'll get me from 0 to 16 in 2 steps in a way that's consistent with the 17 afterwards. So therefore the value of P is 5. 3 marks for that, probably because there was quite a lot of thinking to be involved. There's probably better ways to do that. If you find a better way, please do let me know. But I quite like that what could it be approach. Next we need to work out an expression for the nth term. We've already done a bit of work because we found out that common second difference. So with the second difference of 6, we have to have a 3n squared. So I'm going to write out the 3n squared. Starts at 3, 2 squared times 3 is 12, 3 squared, 9 times 2, 18, and then 3 squared times 4, 3 times 4 squared is 48, 4 squared 16 times 3, 48. So my leftovers, I'm going to do the original sequence, subtract this, we have 5 minus, we have 16 minus, ooh, that doesn't seem right, does it? That doesn't look like it's in an arithmetic progression. So what have I misstate? They are going up in 6. We do go from 0, 5, 11, so 0, 5, 16, 13, does all work. 1 squared times 3, 2 squared times 3, 3 squared times 3. 3 squared times 3 gets us to 27, not to 18. Okay, this might work now. So 16 minus 27 is minus 11. 33 minus that comes out as negative 15. It's worth having these chances to check your work as you go. I knew something was off because this wasn't going to be going up by the same amount each time. And by the way the method works, it has to. We have to be left with an arithmetic progression at the end. So the leftovers then are going down by 4 each time. So they have a negative 4n. Now negative 4n will be negative 4, negative 8, negative 12. It's 1 bigger than that, so negative 4n plus 1. So my answer is the 3n squared and the leftover bits, 3n squared minus 4n plus 1. Before I move on, because there's chances and I've already made one mistake, I am going to definitely check this one for another value. So I'm going to check when n equals 4, 3 times 4 squared minus 4 times 4 plus 1. I'm expecting an answer of 33. And I do get my answer of 33. So I am happy, and that question, although I made an error in the middle, did turn out correctly. Question 13. A matrix question to describe geometrically the single transformation which does that. Now you can either recognise or you can think about the unit square. I recognise this, but let's think about the square anyway. They've given us a bit of space. So our unit square is between 0, 1 and 1, 0. If I were to multiply up, then we get the square up there. Remembering 1, 0 goes to the first column, 0, 1 goes to the second column. So the square's just got 3 times bigger. So this is an enlargement. We use the word for enlargement when it gets bigger in every direction of scale factor 3. Part B. Here are 3 transformations of the x, y plane. A rotation through 90, a reflection y equals x, and a transformation. Okay, so once again you can memorize each of these different transformations. I don't like memorizing things if I can just work them out. So I'm going to work them out each time. So rotation through 90 degrees clockwise about the origin. So that goes down there. So matrix A, well 1, 0, which was that point, is going to rotate round to that point there. So 1, 0 goes to 0, negative 1. So my first column is 0, negative 1. 0, 1 goes to 1, 0, so that's my second column. Part B, not part B, but matrix B is a reflection in the line y equals x. So that's my y equals x line, so my little unit square actually lands back on top of itself, but the coordinates have swapped. So that one and that one have swapped over. 1, 0 went to 0, 1, and 0, 1 went to 1, 0. So now matrix C, we've been told it's matrix A, or transformation A followed by B. Now remembering that we actually have to write them in the opposite order, that way round A happens first, A hits whatever you put next to it first, and then B happens. So this is 0, 1, 1, 0, multiplied by 0, 1, negative 1, 0. Multiplying that out, remember we do row times column, so that comes out as negative 1, 0, 0, 1. And that is actually a really nice transformation. You should recognise that one, but again, if you don't, think about your unit square. 1, 0 goes to the first column, goes to negative 1, 0. That point stays the same, so my unit square is now over there, which is a reflection in the y-axis. Question said, use matrix multiplication to show that C is equivalent to a single reflection. We've just shown that C is equivalent to a single reflection. Question 13, done. Question 14. Y has a minimum value when x equals 0.5. When I saw the word minimum, my first instinct is differentiation. My second instinct is, hang on, maybe it's just a quadratic and I can use complete the square techniques. This is not a quadratic, so differentiation it is. So dy by dx, differentiating a is just a number, we don't need to worry about it. Bring down the power, reduce the power by 1. I do need to rewrite the other term though. I can't differentiate it if it's as a fraction. I need to rewrite it as just x to a power. That's x to the minus 1. Bring down the power, so we multiply by negative 1. Reduce the power by 1. Be careful, reducing minus 1 by 1 gets you to negative 2. Now we've been told we have a minimum at that point. So the min at x equals 0.5 is going to imply that the dy by dx equals 0 at that point, remembering that stationary points occur only when dy by dx equals 0. So that's saying that 24a times 0.5 squared minus 6, 0.5 to the negative 2 equals 0. A bit of a careful calculation here. It's arguably nice to leave things as fractions, it often is. 0.5 squared or a half squared is a quarter, so 24a times a quarter is 6a. A half to the power of -2, well, the negative flips it over, so that's now not a half but 2 to the power of 2. 6 times 2 squared is 24 equals 0, so 6a equals 24, a equals 4. Double checking in the question did say only value rather than values, so only having one solution makes sense, and we are sorted. A equals 4. Question 15. We have a quadratic made from two triangles. We've been told a couple of things. We've even been told what the sine of x is, which is quite nice. That's maybe a bit giving about what method we're going to end up using. We want to find the length of CD. I'm going to label it y over there. X has already been used. But in order to find that, if I'm looking at the triangle ADC, I don't have enough information yet. It looks like I might be trying to use the sine rule with the fact I've been given sine x and I have this 30 and y combo. Well, in order to find that, I need to find AC. I'm not going to run out of letters soon, but let's call ACZ. Well, now ignoring the top triangle, the bottom triangle is right angles with two of the sides known. So in ABC, I can just use Pythagoras. So in ABC, we're saying that 12 squared equals 10 squared plus z squared. 144 equals 100 plus z squared. That's not as nice as I was hoping for. Z squared equals 44. It's really not as nice as I was hoping, because that does not square root nicely. We do have a common factor of 4, so we can square root that to 2 root 11. Okay, that just means that DC is not going to be incredibly nice. But let's go for it. So ADC, now I'm going to use the sine rule, which says that y over sine 30 equals z over sine x. So y equals, multiplying up by sine 30, 2 root 11 divided by 2/3, because sine x was 2/3, multiplied by sine 30, back to our exact triangle. The 30 was up there. This was a 2, 1 root 3 triangle from half the equilateral. Sine is opposite over adjacent, so that's a half. I'm multiplying that carefully. I'll deal with the first part first. Dividing by 2/3 is the same as multiplying by 3 over 2, so the over 2 cancels. So therefore, that side length, DC, is 3 over 2 root 11. Not particularly pleasant, but there's no reason why it had to be whole numbers and such. Non-calculator, so we did have to work a little bit for that, but we got 4 marks for our efforts. Question 16. 16 is our circle theorems. We have ABCD are points on a circle, EDF is a tangent, AB and DC are parallel. There's a lot going on here, a lot of potential things to try and unpick. Prove that W is 180 minus 5x. Proof is the key point there. We need to show carefully every step of our working and justify it. So a couple of things I noticed is we're likely to try and use angles in parallel lines. I can already see a Z shape quite obviously. We're also likely to use, actually, alternate segment theorem looks like it's really nice. So alternate segment theorem says if you've got a triangle hitting a tangent, then the opposite angle in the triangle matches the angle at the tangent. So that one is x and that one there is 2x. Well, let's write that down, tell the examiner exactly how we know that. So CAD equals x and ACD equals 2x by the alternate segment theorem. Okay, and I like to do the questions like this. I like to have each step I do, I write the reason immediately, rather than trying to find it and go to the end. Okay, so I've used the tangent idea. Well, now let's use the Z shape we spotted. So this here is a Z shape using the parallel lines. So that's going to tell me that BAC matches the angle ACD equals 2x as alternate angles are equal. So I have that up here. I also have a 2x. Well, now I've used the tangent, I've used the parallel lines. Let's use the fact that everything is on the circle. So then we have that BAD, which is a big angle at A, plus BCD equals 180 as opposite angles in a cyclic quad sum to 180. Well, now that looks like we're basically there. We've managed to link x and w. Let's just make sure that we fill it in entirely. So 3x plus w plus 2x equals 180. Simplify and rearrange. We've got exactly what the question wanted. End of proof. No gaps in that whatsoever. I've written it as carefully and clearly as possible for the examiner. There should be no confusion in giving full marks for a solution like this. Question 17. Show that that can be written in the form a root 7. Okay. Let's give it a go. That does not look pleasant at all, but it must be doable, where a is an integer. Okay, so first thing I'm going to do is I'm going to factorise inside. I've noticed that I've got two different sets of powers. So I've got 3 to the power of 9 and 3 to the power of 6. In common, we have 3 to the power of 6, which leaves behind a 3 cubed from the first term, kind of using the opposite of multiplying powers, adds powers. And we factored all the other one out. Okay. Well, I can square root 3 to the power of 6. Square rooting is a power of a half. We multiply the powers. So that comes out as a 3 cubed. Inside the bracket still left over, I've got 3 cubed plus 1. 3 cubed 27 plus 1 is 28. And now I'm happy. There's 28's in the 7 times table. At the front we've got the 27. Root 28 we can separate into root 4 and root 7. Root 4 becomes the 2, so we get to 54 root 7. A really horribly looking question that actually wasn't too bad at all. As long as we notice that factorisation, the question falls out fairly comfortably. Question 18. A circle with that centre touches the x-axis at that point. The tangent to the circle intersects the x-axis at R. Crikey. So R's all the way over there. OP to PR is 2 to K. So I need to find the coordinates of R, because I know OP is 10, and then PR I can work out as the difference between the coordinates of P and R, both being on the x-axis, just difference in the x-coordinates. So I need to find R. In order to find R, I probably need to find the line QR. Then I can just sub y equals 0 in and find R. So my new aim, let's kind of keep track of these. So we want to find R. Well, in order to find R, we need to find the line QR, Well, QR, we know one nice fact is that this here is perpendicular. So I can, if I know Q, I can work out the gradient of the radius, I can find the gradient of the tangent. So that means I need to find the coordinates of Q. I'm missing one of them. Well, what do we know about this circle? We know from this part here that the radius is 5. So we have here that the radius is 5. We'll get rid of that right angle for now. So, little sneaky trick, let's put another triangle in. We have the x coordinates for both, so we notice that that change in x is 3. So the change in y is our classic 3, 4, 5 triangle. So change in y there is 4. Well, that's telling us what m is. C had a height of 5, we're 4 higher than that, so m is 9, which therefore says that Q is 13, 9. Okay, well, we've done that first aim. Now we're going back up the list. We now need to find the line QR. So we need its gradient and we need a point on it. We have the point on it, 13, 9. Now we need to find the gradient. So the gradient that we can work out is CQ. The gradient of CQ, well, I already have my change in y, my change in x because of that triangle. So that's going to be change in y is 4 over change in x is 3. Well, we actually wanted the gradient of QR, which is perpendicular to that, remembering that perpendicular gradients are negative reciprocal or negative flip it over. Okay, so now I can go y equals mx plus c on this. So y minus the y coordinate equals the gradient x minus the x coordinate. Okay, now I can simplify this. Do I want to? Maybe. But I've now done that second point. I have found that line, even if it's in an ugly form. So I actually want to find that point R, so I don't need this in any sensible fashion. I just need to sub in y equals 0 at some point. So I'm going to do that without even simplifying this at all. So at R, y equals 0. So that's now negative 9 equals that nonsense. I'm going to multiply this through, I'm going to multiply through by negative 4. That's going to get rid of a lot of the, it's going to get rid of the fraction and the negative sign that I don't like. So times it through by negative 4 leaves this side as 36. Expanding that bracket out leaves you 3x. 3 times negative 13 gives you negative 39. Adding on the 39 gets me to 75 equals 3x. So x equals 25. Well, that gives us our coordinates of r. R is therefore 25, 0. And then PR is 15 between 10 and 25. So therefore that ratio, so OP to PR is 10 to 15, which simplifies to 2 to 3, K equals 3. A really meaty question there, a lot that needed to go on, but having some kind of checklist on what do I need, well, how do I get that, well, how do I get that, well, how do I get that, oh, I can do that, and then reworking through that list of basically instructions you've made for yourself is incredibly important for questions of this difficulty. Question 19. Show that that can be written in that form. Okay, so we want to get rid of the tan and the sine. So let's start by rewriting. I can't rewrite sine. We don't have an identity for sine, but we do have for tan. Tan can be written as sine over cos. Well, that's a bit awkward because that cancels the coses. And I wanted everything to be in terms of cos at the end. Maybe that's a problem, maybe it isn't. But now I have a sine squared. And the other identity we remember is sine squared plus cos squared equals 1. Well, let's use that. So 8 minus, or sine squared, rearranging that, is 1 minus cos squared. Well, I'm back to being happy now. I wanted only cos squareds, and I've got only cos squareds. Let's simplify. And collect like terms. I'm going to write it in the order the question wanted. So therefore A is 3, B is 5, and quite a nice quick question there. For 4 marks, they are incredibly generous when it comes to trig identity style questions. Use your identities, get marks. Question 20, and I've got the beautiful thing at the end saying I'm basically finished. This is the very last question on the paper. But isn't it a horrible one? Solve simultaneously those two. Well, clearly the first one's not linear, so I'm going to have to use a substitution style method rather than a elimination style method that we normally use for linear simultaneous equations. So let's sub it in. So we get 3. I'm not going to write y anymore because I know y is that in terms of x, and again I'm not going to write y in the middle term because I know what it is. So already I've got to the point where I don't have any y's. Now this is just a horrible quadratic in x that we need to try and solve. Expanding out that double bracket, remembering it is a double bracket, so you get a middle term. You're going to get 4x squared times by the 3. Middle terms, 2x and 2x, that's a 4x times by the 3. A plus 1 on the end, plus 3. Very easy to lose that middle term if you're not paying attention to the fact that it's a double bracket. The next term, the thing that worries me here is there's a negative in front. I'm timesing both by negative x, so I get negative 2x and a negative x. The other two terms don't need any simplifying, and there's my next line of working. I've noticed it's a quadratic, so now I just need to slam everything together and simplify. I had 12x squared, I'm losing 2, I'm losing 4, I'm losing 6 in total, so I get to 6x squared. I had 12x, and I'm subtracting an x. I had 3, and I'm subtracting 13. 6x squared plus 11x minus 10. Now to factorise that. Lots of different ways to try and factorise. I prefer the let's just work it out style method. Split the middle is of course perfectly valid. No calculator, so formula is a bit more difficult to use. I can split my 6 into 1, 6 or 3, 2. 10 could be 1, 10 or 2, 5. I don't like using the 6, 1 and 1, 10 very much. They tend to make really big numbers. The middle number's not very big at all. So I'm going to try and use the 2, 3 and the 2, 5. But if I do 2 times 5, 3 times 2, I get 6 and 10. That doesn't make an 11. But the other way does work. So if I go 3x times 5, that gives me a 15. And then 2 and 2x gives me a 4. That does work. Make sure my signs are correct. I need a positive 15 and a negative 4. And I'm factorised. Of course, you should expand that out at least mentally to double check. That gives me values. So x equals 2/3 or x equals negative 5 over 2. I'm not done. It was simultaneous. So I need to go back. Should have really labelled these at the beginning to signpost. So what did I do here? I subbed 2 into 1. And I'm going to go back to 2 here to work out what y is 2x plus 1. 2 times 2/3 is 4/3 plus 1 is 7/3. That's negative 2.5. 2 times that is negative 5 plus 1, negative 4. Let's make that actually look like a negative 4. Now once again, if you did have the calculator, you could check this very easily by typing this into your calculator. We don't have our calculator, but of course, time permitting, you should try and sub these back into equation 1 to try and check. Of course, you're more likely to make mistakes subbing that into equation 1 than you were during the working itself. So something to do at the end very carefully once you've completed the rest of the paper. 5 marks there for some very clean algebra. And that was the entirety of this practice set. Please do let me know if you have any questions from this, and enjoy the rest of your day.